Hi everyone, good evening to all. This is in continuation of videos on centrifugal compressor, and today's topic is for performance of centrifugal compressor for variable speed. So what will be the impact on flow and pressure if there is a change in speed of impeller of compressor? So I'm sure this video is going to be very interesting. Please do keep watching until the end and subscribe my channel. Thank you. So let's begin the discussion for performance for variable for performance for change of the speed on the flow and pressure. Based on the Fan's law, the inlet actual flow is proportional to speed of the impeller, and head rise is a square of the speed of impeller. That means inlet actual flow of the compressor Q is proportional to n, which is speed of impeller, and head can be expressed in isentropic head or polytropic head, which is expressed here as h is proportional to a square of n. So when the speed of impeller is reduced, flow will reduce and discharge pressure, because discharge pressure is linked with the head, will also reduce. If the reduction in speed is huge, discharge pressure becomes too low to overcome compressor header pressure and could lead to surging of compressor. Higher speed will certainly increase the flow rate and discharge pressure. So these are the summary for a speed change and impact on machine performance. And what are the factors that change the speed? One is called electrical grid frequency if compressor is driven by electrical motor. Electrical grid frequency is related with the speed of motor, which is expressed as speed of motor is equal to 120 into F, that is frequency upon number of poles. So any change in the grid frequency will certainly influence the change of motor speed, and since motor is connected to compressor, so speed of compressor will also change. So change of speed is also possible if it is driven by a steam turbine, and if there is a change of speed in a steam turbine, this will lead the change of speed of impeller also. Now let us discuss the performance of compressor in two scenarios: when compressor is operated with inlet guide vane control, and second case when it is a variable speed compressor. This is case inlet guide vane operated compressor, and this is a design case. So x-axis is flow rate and y-axis is discharge pressure. We have shown three IGB position: IGB1, IGB design, and IGB2. IGB design, this is a design point. See, machine is operating at this point with this much flow and this much pressure rise for IGB design position. This is case. Now second case, you can see here, when case number one, when inlet guide vane operated compressor increase in impeller speed is more than design, then what will impact? Design IGB has shifted upward such that the flow and pressure both has increased. You know this formula: Q is proportional to N, H is the square of N. If you look at carefully the same graph, X is mass flow rate, Y is discharge pressure. This was earlier design point, and this IGB design was here, somewhere here. As the speed has increased, all the curves has shifted upward. This was before here, now it is moved here. Design point curve was here, it has moved upward. This was slightly here, now moved this. So if you look at this point, although IGB is still on design, but the flow has increased and pressure has also increased because the curve has shifted upward because of increase of the speed. So you see earlier this was the operating point. Now this is operating point. More flow and more pressure because speed has increased. Now take the case of you know when IGB speed has decreased from the design, I mean less than design, and so the all the curves shifted downward such that flow and speed flow and pressure both has decreased because of this formula. Q is proportional to N, H is proportional to N square. This was original design point, and this IGB was here somewhere. Because the speed has reduced, this point has all the IGB, IG1, IGB design, IG2 has shifted downward. Now this, let us focus on this. This is off design point, which is now shifted downward, and because of this, flow has reduced. Earlier the flow was this point, pressure was earlier this, now pressure is lowered. So lower flow and lower pressure because of reduction of speed. Let us take the case of variable speed machine. This is design point. Let us say this is design point. You know, N1, N design, N2 are three design speed curve. And let's condition N design is the design point where it is operating. This much x-axis is flow and y-axis is pressure. So this much flow and this much pressure is generating at the design condition. Okay. Now let's take the case of increase of impeller speed. You see, because of increase of this speed, earlier this was design point, now because the speed has increased, so we have now another curve, that is N2, and now let's say this is N2. So now this is the operating point because of increase of speed, because Q is proportional to N, H is N square. So now more flow and more pressure as compared to design because the speed has increased. So now it is following the N2 curve, which is higher than N design. Now take the case of when the speed has decreased, same thing. Now let's say it's moved to N1, which is lower than N design. So lower flow and lower pressure because Q is proportional to N, H is N square, proportional to N square. So because of reduction of the speed, the operating point shifted downward. Now let's say move to N1, which is lower than N design, and so that is why lower flow and lower pressure. So I hope you have enjoyed the session, the compressor performance when the speed of impeller changes. So thank you for watching.